Okay, here's another example of using comparison test when determining if a series converges or diverges. In this video, we're going to see how to determine if the series, so this would be summation from 1 to infinity, and the series is, the sequence is 2n divided by n cubed, n squared plus n. So you should look at this series and immediately know that it diverges because the difference in powers, highest power of n in the numerator is 1, highest power of n in the denominator is 2. The difference is 1, so it's comparable to 1 over n. It should diverge, but let's formally see how it's done. Let me remind you of the comparison test, the part of the comparison test that we're going to use here to show that this series diverges. The setup is we have a series starting from n sub 0, which could be 1, could be 7, to infinity a sub n, and the same n equals n sub 0 to infinity of b sub n. The only thing we stipulate is that both all the n's, a n's and b n's are positive. So a n is positive and b n is positive, and that means for all n starting at n sub 0. And then if the b sub n series, so n equals n0 to infinity b sub n, if this series diverges and the a sub n's are at least as big as b sub n, so we would say the b sub n is less than or equal to a sub n. That would be for all n or all n after a certain point. Then the a sub n series also diverges. So remember, this is a divergence part of the comparison test. There's also a convergence part, but we're not going to need that there. So now we have to do some algebra to show the right inequality. We start with n squared plus n, or plus 1. It is less than n squared plus n squared, which is 2n squared. That's clearly true. And 1 over n squared plus 1 is going to be greater than 1 over 2n squared. And if we put 2n in the numerator, so 2n over n squared plus 1 is greater than 2n over 2n squared, which is 1 over n. And now let's label this 2n over n squared plus 1 is our a sub n sequence, and 1 over n, the one we'll be comparing with, is the b sub n sequence. Let's take a look at the series that's comprised of adding the terms from the b sub n sequence, summation 1 to infinity 1 over n. You should immediately recognize that this series diverges because it is the harmonic series. Or you could also use the integral test, but harmonic series is fine. And so the summation from 1 to infinity, a sub n, the unknown series, n equals 1 to infinity, 2n over n squared plus 1. This is greater than the sum, n equals 1 to infinity of just 1 over n, which is our b sub n series. And the right-hand side of this inequality is infinity because the series 1 over n diverges. And because of that, and citing the comparison test, we can now conclude that the series summation 1 to n equals 1 to infinity 2n over n squared plus 1 diverges by the comparison test.